We are going to take a look at the change of base rule for logarithms. Now, on your calculator, your log button is only for base 10. Well, in order to evaluate a log that is not base 10, we have to use the change of base rule. We're not going to look at how to derive the formula here or where it comes from or why it works. We're just going to be looking at the formula and how to use it. Okay, so here's our change of base rule. It says if I have log base a of x, I can rewrite that as log base b of x divided by log base b of a. Notice the x went to the top, the a went to the bottom, and the bases became the same thing. Now, usually what we're going to use for our common base is 10. So we're usually going to use log base 10 of x divided by log base 10 of a. The reason that we're going to use base 10 is because then we can use our calculators. So let's say I need to use my calculator to evaluate the log base 4 of 7. Well, the first thing I'm going to do is I'm going to rewrite it as log of 7. The 7 goes up, the 4 goes down, divided by log of 4. And when I write it just as log without an indicated base, that's assuming it's base 10. So now I can type into my calculator, log of 7. Now, if your calculator automatically gives you an opening parenthesis when you type in your log button, make sure that you close that parenthesis on your calculator before you do the divide. And then divide it by log of, if it gives you that beginning parenthesis, make sure you close the 4. And when you take the log of 7 divided by the log of 4, you should get 1.4036 and then some more decimals. So what that means, if I go back to my original here, it means that 4 raised to some exponent is equal to 7. Well, that exponent is 1.403677 and so on. So you can check your answer here. You can check it by taking 4 raised to the answer you got. Now, if you use just the decimal, like the rounded decimal of 1.4036, you're going to get 6.999. Well, the reason it's not exact is because this is rounded. So that is almost 7, and because we rounded our answer here, we wouldn't expect it to be perfect here. So that would be the exponent that we would need here for x. Okay, the second one, if we did log base 3 of 18, the 18's going to the top, the 3's going to the bottom. So we would have log 18 divided by log of 3. Again, since they don't have an indicated base, it's assumed to be base 10. And when you type that in, make sure again that you close that parenthesis if your calculator automatically gives you a parenthesis. Otherwise, it won't turn out right. So you take your log of 18 divided by your log of 3, and you're going to get 2.631. Again, that means that if I have 3, because that was my base, raised to some exponent, and I need to get an answer of 18, 2.631 was my exponent. You can check it again by raising 3 to your decimal. Now, if you raise it to the 2.631, which is a rounded value, it's not going to turn out to be perfect. So when I took 3 raised to the 2.631, I ended up getting 18.0014. Well, because my original was rounded, it's not going to be perfect, but since it's really close to 18, I know my answer should be right. So those are just very basic change of base rules and how you use them. So now when we look at graphing, we can do our graphing a little bit differently now than what we've done in the past, because I can rewrite this equation now in base 10 and use my calculator. So for this one, before you start to graph, you want to think about a few things like your asymptotes. Normally, our asymptote is at x equals 0, is where we have a vertical asymptote. Well, now I have a shift here. I have a shift of left 2, so that means my vertical asymptote is going to be at -2. So I'm going to start by putting my dotted line here where x is equal to -2. And I know that I cannot have anything less than -2. So my domain for this one, if I needed to state my domain, would be x has to be greater than -2. So now we can start by rewriting our formula. And so I would have log, well, the x plus 2 goes to the top, so I'm going to have the log of x plus 2 divided by, and then the 4 goes to the bottom, divided by the log of 4. Now I can do a table of values, and with my table of values I have to make sure I pay attention to my domain. I can have anything that's bigger than -2. So I'm going to start with -1 and then do 0, 1, 2, 3, and 4 and see how far that takes me. So I'm going to plug each of these values in to my change of base formula here. So the first one would be log of -1 plus 2 divided by the log of 4. Well, I'm going to do the -1 plus 2, so that would give me the log of 1 divided by the log of 4. And then you can type that into your calculators and get an answer of 0. You can do that for each one of your values now. So go ahead and plug each of these in and see what you come up with for your table of values. Okay, when you plug each of those values in, you should have gotten this for your table of values. If you want to extend your table of values to a few more points, you can. If you want to just graph these and see how it looks, you can do that also. Okay, now I've noticed that my y values aren't that incredibly big, so instead of going by ones, I'm going to go by 0.2 for my y scale. Once I get my scale marked off, I am going to go ahead and plot each of those points, and then I'm going to decide if I think I need more points or not for my graph. So go ahead and plot the points that you have. Okay, once you get your points plotted, you can decide if you want to do more points or not. I'm pretty happy with the way my graph looks, so I'm going to go ahead and sketch my line in there. And now remember, as I approach my asymptote, I cannot cross it. So my graph is going to look something like that, a nice smooth curve going in there. So now when you're doing graphing, you can use the change of base rule to get more points for your table of values. Start by rewriting your formula and then decide where your domain is going to be so you know which x values to pick, and then you can do your table of values from there.